Hello everyone, yet another math problem. So we have a system of equations with real solutions. You can see there, okay? Real solutions, and the system of equation is x plus y plus z is equal to 3, x squared plus y squared plus z squared is equal to 3. For this I have two solutions, one purely algebraic one and one with using a linear algebra. So if just using regular algebra, I'll start with this one. Okay. So how do we do this? Okay, we would like to utilize the fact that squares can't be less than 0. And yeah, exactly. So how do we do this? Okay, so we would like to somehow add these up and factorize. So we would get well, optimally we would just get squares plus one another, which is equal to 0, and therefore we would know that all the squares have to be equal to 0. So how would we do this? Well, okay, so we know the factorizing rule. We have a squared plus 2ab plus b squared, or a squared minus 2ab plus b squared. So I suggest that we take this, we multiply this row by 2 and move it down here. So if this is row 1 and this is row 2, then here we have 2 minus, well, yeah, row 2 minus 2 times row 1. This would give us x squared plus y squared plus z squared minus 2x minus 2y minus 2z is then equal to 3 minus 2 times 3, which is minus 6. So therefore, well, yeah, I can write 3 minus 6, which is equal to minus 3. And now we can do what we did before, or what I talked about before, factorizing this. So okay, x squared minus 2x. We don't regard the extra b squared at the moment. We will just fix so that we make a parenthesis which suffices these two. So therefore we have x minus 1 squared, and the same with the y's and same with the z, and plus y minus 1 squared plus z minus 1 squared. Okay, and now we regard the extra plus 1s here. Okay, so we get a plus 1 plus 1 plus 1, so we have to take a minus 3 to compensate, and this is supposed to be equal to minus 3. So these just cancel out, and this gives us that this thing over here is equal to 0. And this is exactly what I talked about before. Somehow I knew the problem in advance, maybe, or the solution. Okay, so yeah, now we have that something squared plus something squared plus something squared is equal to 0. And since all of these squares each are bigger than or equal to 0, that means that all of them have to be equal to 0, meaning that x is equal to y is equal to z is equal to 1. And this is our only solution, because here we have done nothing that could ever, we'll say, create new answers. We haven't taken any square root of anything. We haven't taken anything to any power. We haven't used any like exponential or anything. This is just pure algebra, and therefore this is the only solution. So yeah, that was the first method, and then now we move on to the linear algebra. Linear algebra 1. So, I'm back. Now, if you may be taking your linear algebra course, or you're just a smart motherfucker, then you would see this system of equations as a plane and a sphere. So, okay, this plane, we'll start with that, has the normal vector just 1, 1, 1. And, well, this gives the normalized normal vector to be equal to 1 over square root of 3 times 1, 1, 1. And then for this circle, we know that it's centered at the origin point, 0, 0, 0, and its radius is the square root of 3. And for this, okay, the question, okay, we have a line and we have a plane and we have a sphere. If the plane is outside the sphere, we have no solutions. If the plane is inside the sphere, meaning that then we get an infinite amount of solutions because we get a circle with infinite amount of points, obviously. And if it's just on the line, or sorry, just on the edge of the circle, then it's tangential and there's only one solution. And so how do we find this? Okay, the difference was basically between these cases. What is the difference actually? The difference is the distance from the plane to the point of origin. If the distance is greater than the radius, then it's outside. If it's smaller than the radius, it's inside. And if it's equal to the radius, then it's tangential, and there's only one solution. So how do we find? So basically now we just need to find the distance between the plane and the point of origin. And for this, you could use the plane point formula. I don't like that personally. I would rather just pick a random point. Okay, so I can draw a quick little sketch here. So here we have y, x, and then some z here, maybe. Okay, and then we have a little sphere here, and then some plane. I'll just draw it like it's tangential. And then we know that, okay, the normal vector of the plane looks something like that. And then we know that, okay, the vector from this to any point in the plane, take that vector and use the scalar product with the normalized normal vector, then we will get the distance between the two, because this is basically how far it goes in the orthogonal direction. So, give me a random point in the plane. I can say something that suffices this equation. Okay, 3, 0, 0 works. So we want now, okay, 3, 0, 0 scalar product with the normalized normal vector. So, okay, we will write the normalized normal vector is the square root of 3 times 1, 1, 1, and have that scalar product or dot product with 3, 0, 0. And what is this? This is just 3, again, then plus 0, plus 0, and then 3 over square root of 3, that is just equal to the square root of 3. And therefore, it's tangential. And there's only one solution. And what may that solution be? To find this solution, we just move. Well, okay, actually, since our normal product is our normal vector is kind of pointing that way, but okay, it doesn't really matter. All we have to do now, since we're going from the origin point to the plane, and we know that this is the normal vector, then the point that tangents the sphere is just this times the normal vector. So the square root of 3 times the normal vector, the square root of 3's cancel out. So that is just 1, 1, 1, meaning that x is equal to y. Sorry, x is equal to y is equal to z is equal to 1, which is the same solution as we got before. And that is also the only solution there is. So that was the second method, and I am therefore done. Please share your comments in the comment section and like and subscribe, and please tell me if there are some other things you would like to know about or any problems you want me to solve. So yeah, that was basically everything for me. Thank you so much. I'll see you some other time. Bye bye.